It's new
Is it
product
time for new?
Yeah, it's
Okay.
new product time. So the first thing I'm going to show Lady Ada is we're completing our Gawkin tour with
Yeah.
videos each week.
Okay.
And here's the
I'm
first
over
Gawkin
here.
video.
Everything's
Yeah,
fine.
no, I know.
Whoa.
Yeah, so this is the Strand Beast, and this is a wonderful video.
Whoa, that's super cool and creepy.
Yeah. This is a kit you can buy at Adafruit, build, and this is what it does.
That's lovely.
Yeah, isn't that great? Okay.
Nice work.
All right, so
Okay.
Lady Ada, we're
They
going
got the lights
to,
on because I'm going to show off stuff.
Yeah, so here we go.
Okay, do this thing.
We got these cell phone antenna looking things. What are these?
Yeah, they're cell phone antennas.
Are they cell phone antennas?
They're cell
It's as
phone-
if you're putting things in the store each week because we're going to be building an open source cell phone, Lady Ada.
We might be, but I had to get these antennas in first.
Oh.
These are two little antennas. I could show them on the overhead real fast, just because
Okay.
the scale is hard to tell. Yeah, they're shorty little antennas. They have SMA connectors, which is pretty common for cell phone stuff. And there's one that's right angle, and it rotates around. But once you tighten it, it kind of sits in place. And then there's the straight style, which also rotates, but doesn't really matter because it doesn't
Okay.
matter. Yeah, they're both GSM. They do, I think, quad band. We have the data sheet with the thing. And they have very nice VSWR. I think is less than 2, which is pretty good for like pretty basic antennas.
Okay.
We'll be using these for future cell phone stuff, such as cell phone shields, cell phone breakouts, and DIY open source cell phones, which we don't have quite yet. So
Okay. Yeah.
we're just
All
getting this ready.
Next up, more of these things. We had these last week too.
Yeah, these I'm not going to show because actually they're too small. These are DIY stereo plugs and jacks. So this is if you're making your own connectors or cables. I just always use these. They're so handy. We have the plug type, which we just showed you, which is a stereo plug, which is tip ring sleeve. Hey, can you click the first one? Yeah, that one. So you can see tip ring sleeve. So it's stereo, ground, left and right. And then next photo. And then next photo. And then you unscrew it, and then there's 3 tabs. There's the ground tab and the 2 side tabs. And then there's a nice strain relief spring as well. So you can make your own cables, really high quality cables. And we have the matching connector, which is the jack.
I like how you brought out this like old shuffle.
Look.
Yeah.
This is what I got. So it just shows it plugs in, whatever. It's an audio, it's audio jack. 'Cause
Okay, then you got this
know,
one.
these photos are so high res, you can't tell if it's like a 1/4 inch or 1/8 inch. So these are 1/8 inch. And this is the jack, which is, it's capsule-y looking because it's bigger, and it snaps in, matches perfectly, but it also matches any other stereo connection. So this is good for making sometimes you have to make a special cable with splitter or whatever. So again, 3 tabs. Screw it together when you're done. Get strain relief. That's me, Lady Ada.
Yeah, sometimes.
That's it. So we have a couple different sizes now. I think we have like 1 or 2 more coming in, but I think we have almost all of them by now. We have 1/8 in, 1/4 inch, stereo, tip ring sleeve TRS,
Yeah.
2.5 millimeter. So like it kind of covers like all the weird audio connectors,
Okay.
which is handy.
Next up. Hits keep coming.
Slim style. USB mini B. This is for making your own USB cables. We have them in many different varieties. We got the USB A type, B type, mini B, micro B, whatever, all the different types. This is a mini B, and this is sort of a slim Apple style, but of course it's not only used for Apple cables. It's just what most people are familiar with. Has a nice kind of over molded look, but you don't have to like get, it's for custom cables or custom breakouts. Once in a while you want to do like a weird custom thing, or you want to break out the data lines or something, or do something unusual. So this is a really good connector for that.
Okay.
And we don't have the picture of it snapped apart, but if you go to the product page, it snaps
Yeah.
apart, and then you solder to these little tabs. They're not too hard to solder to, and you get access to all 5 pins, and then you can snap it together, and there's a little strain relief.
Yeah. Okay. Next up. This is a transducer, right?
Yeah, hold on, I have to get my demo ready. This is
I'll show these nice pictures.
a
first.
surface transducer. We had a little bone conductor, and this is sort of similar to that, except it is a, hold on, let me get this power thing going on here. It is a larger version. It's not a bone conductor. I mean, you could use it for bones, but it's kind of big. What it's actually meant for is to use in, it's meant to be used in tabletop transducers. So can we go to the overhead?
Okay,
and
we'll
I'll
go to
show
the
this
overhead.
off. So yeah, we have this surface and I have the transducer. And when I put it down, it turns the whole thing into a speaker. So it's not like the bone conductor, which you have to place up to your bones. This is like much bigger than that. But it has this like rubber bumper thing on top, and then this is weighted. It's a little hefty. That coil holder, so that when you put it onto a surface, the rubber kind of sticks to the surface and it turns that surface into a transducer. So it's good for like tables, or you can actually put it up against a wall if you can get it to stick to a wall. You can put it against like bowls or cups or whatever to turn them into cavities for resonance.
Yeah.
This is a much higher output one than the little one that we have, the little bone conductor. It's a 4 ohm 3 watt. So you need like an amplifier. Use one of the amplifiers in the store. You wire it just like a speaker, and then you just put it down when you're ready to turn on the music.
Okay. All right, moving right along. We still got a long way to go. We got a bunch of these.
Yeah.
So
these are 8x8
Off.
matrices. We had these already, but in round,
Yeah.
and now we have them in square pixel because everyone loves square pixels. I love square
Okay.
pixels. I finally got square pixels. We have them in blue, bright blue.
I really like these photos, so let's do a quick photo tour.
Okay, let's just do a photo tour.
Yeah, so
Blue.
the blue.
We have them in orange, amber, whatever.
Yeah,
One or
that's
the other.
orange.
Orange. Yellow. Nice yellow. Pure green, which is the 3.4 volt green, not the 2.3 volt
Yeah.
green.
And then we
it's
have
green.
another type.
And then white. Yeah, has that yellow phosphor. Really bright white.
Yeah, you can see how bright it is.
It's so bright you can't, like, the photo doesn't look quite right. You have
Yeah.
to look at the reflection to see how bright it is.
Yeah, and then when you hook these up, you can do all sorts of things with them.
Yeah, we also have them as backpacks for, let me get this set up. And it's actually a good way to show them off as well. Hold on.
Take your time. I'm showing some nice
Yeah,
photos
you
here.
show off those photos while I get this
Yeah.
demo going. What happened to my demo? Hello? Uh-oh. There you go. Okay. Can you go to the overhead? Okay, so this is the demo, and I turn off the light to make it clear. It's flickery because it's freaking out the camera because it's so bright.
Yeah, you could put it off to the side a little bit. Sean.
Yeah. There you go. So this
That's
is
cool.
the demo showing the square pixels. They look really good. And I'll actually, I put headers on this so I can swap these out. So that's the bright white. You can tell because it's bright white. And then this one is yellow, I think. Yeah. So this one is like the yellow color. It's a little hard to tell that it's yellow, but it's yellow. And then let me get the blue one. And then the backpacks just make it easier to use. And you can use the matrices if you want to do multiplexing on your own. A lot of people don't want to, so if you get the backpacks, it adds like $6, but you can just do everything over I2C. This is blue. The blue is like really, really bright. You can see how bright it is. And then we also have amber. And then somewhere around here, oh yeah, I've got the green too. Hold on. And this is the amber color. This is a little bit redder than the green. And then we have the green one, which is really, really bright too. The green one is like, for some reason, like super crazy hella bright.
Yeah,
But that's good. You can always dim the display if you want. The backpacks have the ability to dim them. So I always suggest like getting them with the backpacks. But if you want to if you're like, oh, I have 16 pins or whatever, and you're crazy for multiplexing, go ahead and multiplex them. I just love the square pixel. I think they're so much cuter than the round ones.
Okay.
Round one's kind of classic though, so.
Yeah.
And we'll be getting, we're missing a couple colors, like we're missing red and a yellow green. The ones that I got, the samples, I didn't think were bright enough. So we're getting them, we're getting more made that are brighter, and we'll have the other colors later. But these were good enough to get started with.
Okay.
All right.
Next up, I really like these.
Oh, the little mini NeoPixels?
Yeah, so these are really beautiful. So these are a little different than your regular old LEDs. They have 4 pins. Like, what's going on here? These aren't just like,
Yeah,
what's
well,
going on here?
RGB LEDs have 4 pins, but these are smart NeoPixel type LEDs. They have a WS2812 chip inside of them. You can
it's like-
almost kind of see the chip. I don't know if we have
So-
a photo that shows the chip.
No, we're going to do a close-up. So what you're saying to me is that these are like breadboardable NeoPixels.
Yeah, these are breadboardable NeoPixels. And we put the little lens flare on them, which I think is kind of cute.
No, that came out straight up. This is just an iPhone that took this photo.
We gave it a little bit of glamour, just to make it clear. They're shorty 5mm clear LEDs. We also have them in diffused 8mm. These are different. Some people want them in this, and these are a little brighter than the 8mm, but they're not as diffused. So there's a trade-off. There might be situations where you want to have more of a sparkle, and I have it just powered here from a Trinket, and you can just sort of see like how incredibly bright these are.
And
They're
this
so
is
bright.
one of the things that I should be clear. You can individually control each one of these.
That's right. Each one of these
Yeah.
is powered from a data in pin. It's yellow wire, which the way they work out, they're really easy to breadboard because you just connect them one after the other, and the data in goes to the data out pin. And so these are just like NeoPixels or any other, WS2811 or 2812, whichever, same thing. But they're through-hole style, and then they're little clear LEDs. But they're a little shorter. You can kind of see how they're a little half height. That might be okay. I mean, you can diffuse them with stuff, or you can use them as point source lights. They're quite bright and very unidirectional, very point sourcey, because there's like the way the lens is made. They're not diffused.
So there's not anything. So just someone had a question about the previous thing.
What?
Well,
Yo.
there's no such thing as an RGB version of these yet, right?
No, there are, but we don't have a driver for it.
Oh.
And for the
I've
RGB,
not seen those yet.
No, I've seen them, but they're a real pain in the ass because
Oh, really?
you need like so many pins to drive them. We have bicolor, which is a low-cost way of doing it. The thing here's the deal with RGB: if you can't individual control every color really nicely, it kind of isn't as much fun. So I'm thinking about how to, I might do it eventually, but also the RGB ones are kind of pricey. Like the matrices are like $20. So for that price, you can get like a 16 by 32, matrix, like the LED wall style matrix. So I have to think about it. I like these little matrices because they're small and they're simple, and like a lot of people are kind of happy with one color. And we also have bicolor as well. We have a red and green with mixed to make orange.
All right, moving right along. We got some Frams.
Fram. These are Framtastic.
Yeah.
We have Fram in both I2C, 32 kilobits, 32 kilobytes, and then SPI Fram, which is I think 8 kilobytes. Right?
Okay.
Yeah, 8 kilobytes and 32 kilobytes.
Right.
So this is kind of weird stuff. It's, if you know what SRAM is, it's a sort of a RAM that you can store fast and read fast, but it loses data when the power lost. And then there's like EEPROM/flash, which is you can also store data, but it takes a while to write the data. You can read it very fast, but writing it takes a while, and usually you have to write it in blocks, and you also need to do this 12-volt erase thing. Usually it's built in, but it's kind of, with Flash, it's like usually you have to do a deal where you erase a page and then you can rewrite that page, so you have to buffer it. So it's a little bit weird if you want to stream data to Flash, especially if there's breaks, because you can either lose it or you have to overwrite the page over and over again. So FRAM or FRAM is kind of in the middle. It's ferroelectric RAM. It's kind of like a recently popular thing. It's not a new invention. But recently they've become more popular, and we thought it was kind of interesting. Might be used for data logging. This kind of combines the best of SRAM and Flash EEPROM. So, like SRAM, it's instantaneous. You can read or write like 10 to the 12 times. I mean, basically, you don't have to worry about wear leveling or anything like you do with Flash in most cases. Way more than the 10,000 writes that you usually get with Flash. This is like a million times more, I guess. It's a lot. I don't worry about it too much. And when you lose power, it retains the memory. So it instantaneously writes, but you don't have to worry about page writing. You don't have to worry about erasing the page beforehand. And it stores it instantly, so when you lose power, it's saved. So it has the speed of SRAM with the non-volatility, the power off memory storage of Flash EEPROM. It's a nice combo.
What does FRAM stand for?
Ferroelectric random access memory.
Wow.
Because you can randomly access any
Okay.
part of memory. And we have an SPI and I2C. We got the 5-volt safe versions, which means that we got the largest that were available in 5-volt. And for some reason, the 5-volt I2C and the 5-volt SPI were not the same capacity. The I2C is much larger, but it's not as fast as the SPI. The SPI you can clock at 20 megahertz, so you can read or write at 20 megahertz SPI clock, but it's only 8 kilobytes. The I2C is 32 kilobytes. I know it's very similar. We have Arduino libraries for both, but they're really easy to use. You could port it to any microcontroller trivially. They're actually kind of like drop-in replacements for 24 or 25 series logic. So if you are series memory, so if you're using 24 LC or 25 LC series Flash or EEPROM or whatever, it kind of acts the same.
Okay.
FRAM.
Next up.
Fram it up.
I currently have some issues that I think only the charger doctor could.
Okay.
Just
Do you want to get the
get a
charger doctor in here?
Current.
Current.
It's kind of funny.
Okay.
Okay. So this is a charge doctor.
Charger Doctor.
What's a charge doctor do?
The Charger Doctor is something that I actually got for debugging the Power Boost, which we'll talk about next. And it's this little like inline little dongle that you power to USB and it passes the data lines and then it does here's a Charger Doctor. Hold on, let me see, maybe it'll look a little better if I turn on the light. 1 second.
All right. The charge doctor is in.
The charge doctor's in. So it's a little dim just because it's light, but it displays the voltage and the current. And this is from the Power Boost. You can see it's like 5.2 volts. And then what you can do is like you can plug in, like for example, I'm going to plug in an iPhone into here, and it'll tell me. I got the phone here, and it'll say, oh, it's drawing, 25 milliamps, 28 milliamps. It's actually going down because I just recently charged this phone up. But you can sort of watch how much current and voltage is being drawn. It doesn't do watts. Sorry, it does voltage and amps. It's not open source. I don't have the code for this. So you can open up and reprogram the PIC or whatever's inside. But other than that, I have no, this is what you get. But it's very handy for debugging because, you can see what your current draw is at all times. It's kind of chunky, but works really well. It's low cost, simple. So I use it all the time when I was debugging the Power Boost to see like what's the voltage I'm actually getting at, what's the current draw, is it working at all? Handy little guy, Charger Doctor. Okay. Doctor's in.
One question back on these real quick. Someone wants to know, can you use these displays?
What, the LEDs?
These for the Times Square watch.
No, it's actually a different size.
Different size?
These are a little bit smaller.
All
but
right.
I'll try to get square ones for the Times Square watch.
Okay.
I think I tried to and they didn't have them, but they had these. It's a bit of a
All right.
journey sometimes getting LEDs made.
This is our last product of the night, world premiere. Been worked on forever.
Yeah.
This is the logo for the series of products that we're doing. This is the Power Boost 500 LED.
Yay.
This is it. It's here. This is it. These
Yeah,
are
I finally.
photos.
Well, I've been working on this for like nearly 2 years because not like continuously, but I started this a long time ago. It was called the Minty Boost Pro, and it was going to be the TPS 61029. And I actually got the design done. I had the stencil made. I had the PCBs. I had like parts. I had everything ordered. I had it ready to go. And then 1 out of 10 would blow up on the tester.
Yeah.
And I could never figure out why. And like TI kind of wasn't very helpful. And I was like, I can't sell something that 10% of the time breaks during test.
Yeah.
Like, and I wasn't even doing anything weird, but I was like, whatever I'm doing in test is what people are going to be doing, like connecting, disconnecting loads, and like measuring the current. And I was just like, one day I'll figure it out. It's some instability issue.
So you
but in the
folks
meantime, I even made something better.
You folks who watch this, you get Ask an Engineer for just 1 hour once a week. I get Ask an Engineer 24 hours a day. So for the last 2 years, this has been in our lives.
Yeah.
We're just like, it was just this ongoing thing. So this is a really big deal for us. So what do you want to do? Do you want to talk
I'll
about
show
it more?
I'll show this. Let's show the photos. Can we show the?
Yeah, which photo? This one?
The straight. Oh, you didn't get the straight on photo.
Which
Ooh.
one? No, we got this in right before the show.
Okay.
Yeah.
Can you go to
I got this one.
ISO photo?
This
Can
one?
you zoom in on the board?
Yeah, I can do that.
Okay. Why don't you zoom in on the board? Okay, that's good enough. Yeah. That's fine. Zoom in.
Yeah, we got it.
Then I can kind of talk about it. Yeah. Wow. Nice quality photos. You can show the photo.
Yeah.
So it's a little boost converter. It's a lot like the idea behind the Minty Boost. It takes battery in and gives you a USB connector or 5 volts out. And I kind of wanted to make something that was really flexible. So this uses the TPS 61090, which is a chip from TI, and it's a 2 amp boost converter. And what that means is that you can draw 2 amps from the battery, basically, like here and there, like technically, but it's 2 amps max through the battery connection that goes through the switch in the inductor. So if you have, it works down to 1.8 volts. So if you have a 1.8 volt input, which has like maybe 2 kind of dead batteries, it can boost it up to 5 volts at 500 milliamps. And if you have a LiPoly battery or lithium ion battery, which is 3.7 volts, it's almost twice as high, you can draw 1 amp. So the higher the input voltage, the more current you can get out. So it says 500 because that's the guaranteed voltage. If you can power it, it'll give you 500 milliamps. But you can actually get up to 1 amp from a lithium ion or lithium polymer battery. The chip in the middle there is the controller, and there's an inductor, and it's a synchronous boost converter, which is something I really like. One of the nice things about synchronous converters is, first off, they're more efficient. So it's more than 90% efficient in converting voltage. And if you can turn it off and with enable pin, but by connecting the enable pin to ground, and you don't need a switch to disconnect the output. It actually disconnects on the inside of the chip the output from the input. So all lower cost boost converters, if you try to turn it off or disable it, it'll just won't boost. It'll just let the battery voltage go through, so it never actually turns off the output. It's kind of a side effect of most boost converter designs, the way that the diode and the inductor works. In this case, the diode is simulated with FETs inside of the chip, so it has a true disconnect. It's pretty efficient. I measured, boosting from a LiPo battery up to 5 volts, 500 milliamps. I got like 92% on the tester. The tester checks the efficiency, so you get like 92%. You can get up to 95, if you've got exactly the right kind of voltage input and voltage output. But in general, it's over 85%. So it's pretty efficient. So if you don't want to have to get it, it's often more efficient than a regulator, like a linear regulator. So if you have couple batteries, maybe better just put 3 AA batteries on this or 2 AA batteries and get 5 volts out. There's 2 LEDs. There's a power LED, which is in the corner there next to the USB, and you can see it lit, and it tells you when the power's good. There's also a low battery LED that's red, and you can't see it because this battery's charged, but it lights up when the battery voltage drops below 3 volts. And it comes with a USB connector, so you can solder it in, and it has iOS resistor, so you can plug in any iPhone or iDevice, or actually works with like Android stuff too, by the way. Everyone kind of followed the same convention, and it will recognize and work well. So it's really, I want to design it for like everything. You use it to charge your gadgets, you can use it to power your Arduino, you can use it to power your Raspberry Pi or BeagleBone or other single board computer. Anything that can charge over USB, because it's guaranteed to provide 500 milliamps, and that's the USB kind of standard. You can charge with this, and it's a little bit more flexible than a battery pack and more powerful than the Minty Boost. And you can turn on and off with the enable pin, and there's a low battery output, and there's breakouts, has a JST jack. It's just kind of like an overall fixes the problem of I need 5 volts in a project, and I don't want to get a regulator, and I don't have exactly 5 volts. So this boosts up your rechargeable battery to a nice clean output.
Okay, so I want to know what's the. I'm going to blend some questions of this.
Blend.
Yeah, you answered a bunch of the questions people
Yeah,
had.
I have to-
The number one thing was can this power Raspberry Pi? But that cylindrical
Absolutely.
battery, how much power can that deliver? This?
Yeah. So can we go to the overhead real fast?
Yes, of course.
I'll show this fast. So I'm using the new LiPo that we've just, it's actually the original LiPo, which has a weird thing. So this is not actually what's in the store. It's an earlier sample, which now becomes like my property. And this is a 2,000 milliamp hour battery. So the 2,000 milliamp hour battery, it can provide up to 2 amps. Right now it's just like charging a phone. But from this, it can provide 1 amp for 1 amp continuously for maybe like 3/4 of an hour. Because you have to figure out what the capacity is and then divide by the efficiency and then do the math, which I'm not going to do in my head right now. But these larger LiPoly batteries are lithium-ion batteries. We have them in the store. Anything larger than 2,000 milliamp hours, it would be great. You can draw up to 1 amp, and then if you have a charge adapter, you can see exactly how much current you're using. Most Raspberry Pi projects don't use the full amp. I know that they say it can go up to 1 amp, but really, I put it like an LCD and a Wi-Fi and it's downloading, and it gets to like 500 milliamps usually. It's good to have a little bit of headroom, but it doesn't actually go that high.
So the little resistors are for what, iOS stuff?
Yeah, for iPhones, if you want the iPhone or the iPod or whatever to kind of be happy and not say this charger's not supported, you need to have these little resistors. So I added those in because just a little more space, so that you can always charge in. You can plug in any iOS device and it will say, "Badink, no problem charging."
Yeah, if not, it'll say not supported and it scares you.
Yeah, and if it sometimes doesn't charge or whatever, this will work with any Apple device. This is the reverse engineered Apple resistors that I did a couple of years ago.
Yeah, there's a good article about it. Okay,
Yeah.
Lady Ada, that was New Products. Good work.